You reach for the salt shaker without thinking. It's just there, on the table, next to the pepper. You shake it over your food before you've even tasted it. The whole action takes less than 2 seconds. But for most of human existence, salt was one of the hardest things on Earth to find. Not inconvenient, not expensive, genuinely, physically difficult to find. Your ancestors spent hundreds of thousands of years searching for it, craving it, sometimes dying without it. And the craving you feel right now, that pull towards salty food, that reflex that makes plain food feel unfinished, that is ancient. That is not a preference. That is a biological instruction written into your nervous system before the first human being walked upright. The question is, when did we figure out how to answer it? For over 300,000 years, Homo sapiens lived without salt as a substance they could collect, store, or trade. They had no mines, no evaporation ponds, no ceramic jars to keep it dry. What they had was a body screaming for sodium and a landscape that hid it in unpredictable places. A salt lick here, a mineral spring there, the blood of a freshly killed animal still warm on the ground. That was it. Your body needs sodium to survive. Not wants, needs. Your heart uses it to fire. Your neurons use it to send signals. Without sodium, the fluid around your cells collapses, your blood pressure drops, your muscles stop contracting properly. A human being can die of sodium deficiency in days. Your body knows this. It has always known this. So it built in an alarm system, a craving so sharp and specific that you can feel it right now if you go long enough without eating salt. Ancient humans felt that alarm constantly, and they had no reliable way to answer it, which raises a question that researchers spent decades arguing about. Not just when did humans start eating salt, but when did they start going out of their way to find it? When did sodium stop being something they stumbled across and start being something they hunted? The first clue doesn't come from a laboratory. It comes from watching animals. Every large herbivore on Earth seeks out sodium deposits. Elephants in Kenya travel up to 40 kilometers to reach mineral-rich caves in Mount Elgon, where they use their tusks to chip salt-laced rock from the walls and eat it. Deer in North America lick road salt off the pavement in winter. Gorillas in the Congo Basin eat sodium-rich aquatic plants and soil from riverbanks specifically to supplement their mineral intake. These animals are not doing this by accident. They are responding to the same biological signal your body sends you when you reach for that shaker. Your ancestors watched this. They were close observers of animal behavior. They followed herds. They tracked migration patterns. And the places animals returned to again and again, the mineral springs, the salt licks, the sodium-rich river clay, those were the places humans returned to as well. For hundreds of thousands of years, the strategy was simple. Go where the animals go. Eat what the animals eat. Let the landscape tell you where the sodium is. But that strategy had a brutal flaw. Salt licks are not evenly distributed. They cluster in certain geological regions and are almost entirely absent in others. The East African Rift Valley, where much of early human evolution played out, is actually relatively sodium poor in many areas. Anthropologist Timothy Johns of McGill University spent years studying the relationship between mineral availability and early human diet. And his research suggests that sodium scarcity may have been a persistent low-grade stress for early hominins. Not a crisis, but a constant background pressure. A body always slightly undersupplied. A craving never fully answered. That pressure shaped behavior in ways that are still visible today. In 2009, anthropologist Sarah Blaffer-Erdy of the University of California, Davis published research on cooperative breeding in early human populations. Her work was primarily about childcare, but embedded in it was something striking about resource sharing. Among foraging groups, rare and high-value resources, things like honey, fat, and mineral-rich foods, were shared more broadly than common ones. If one member of the group found a salt deposit, it didn't stay private. It spread. Because the group's survival depended on sodium reaching everyone, not just the finder. That is how ancient salt sharing worked. That is how early humans kept each other alive. Not through trade, not through ownership, but through the same cooperative instinct that made our species survive when stronger, faster animals did not. The numbers tell one story. The lived reality tells another. Picture a group of early humans, maybe 25 people, moving through what is now Ethiopia roughly 100,000 years ago. They are following a dry riverbed north because the rains have been poor and the game has moved. One of them, a woman in her 30s who has made this route before, leads them toward a bend in the valley where she remembers the clay smells different, where the earth has a faint whitish crust after it dries. She has been here twice before in her life. She knows what that crust means. They stop. They scrape the earth with flat stones in their fingers. They eat the clay directly from the ground, their bodies pulling sodium from the mineral-rich soil before they have any other way to extract it. The children eat it too. The taste is sharp, slightly bitter, nothing like the clean salt, but their bodies respond immediately. That alkaline mineral signal registers somewhere below thought, somewhere older than language, and it feels like relief. They sleep there that night. They stay 2 days, and then they move on because the deposit is not large and not permanent, and the sodium it contains is already beginning to run out. That was the rhythm of salt for most of human history. Find it. Use it up. Move on. The Hadza of Tanzania, one of the last surviving hunter-gatherer populations on Earth, get most of their sodium from meat and from the organs of the animals they hunt. A Hadza hunter who brings down an impala eats the liver almost immediately, still warm, and the sodium inside that organ does real physiological work. Frank Marlowe, an anthropologist at Cambridge University who spent years living with and studying the Hadza, documented the way their diet is naturally high in animal products during certain seasons, which keeps sodium intake adequate without any external salt source at all. The Hadza do not season their food. They do not reach for a shaker, but their bodies are not deficient, because their food still carries the sodium that processing has stripped from yours. The same pattern appears among the Tachakung San of the Kalahari, studied extensively by anthropologist Richard Lee of the University of Toronto throughout the 1960s and 1970s. Lee found that the Kung consumed roughly 690 milligrams of sodium per day from their natural diet. No added salt, just food. And that number, 690 milligrams, is almost exactly what modern cardiologists now consider the ideal daily sodium intake for a healthy human heart. Your ancestors were hitting the target without trying, because the food itself was right, and then agriculture arrived and everything broke. But before that break, something else happened first, something that changed the human relationship with sodium permanently and set in motion every salt road, every salt war, and every salt empire that followed. Humans learned to make it. In 2011, archaeologist Olivier Weller of the French National Center for Scientific Research published findings from a site in northeastern Romania called Lunca, in the Name County region. What he found there pushed the known timeline of deliberate salt extraction back further than almost anyone expected. The site contained ceramic vessels, fire pits, and structural remains dating to approximately 6000 BCE. Roughly 8,000 years ago. The layout matched what Weller described as a deliberate salt production facility, a place where people boiled brine from a natural salt spring to extract crystallized sodium. This wasn't accidental contact with a mineral deposit. This was a system, a process. People were returning to this location specifically, repeatedly, to manufacture salt. But here is what stopped researchers cold. Lunca wasn't a civilization. There was no city nearby, no written language, no complex government. The people using that site were Neolithic villagers, early farmers who had only recently stopped living as nomads, and they were already running a salt production operation complex enough to leave an identifiable archaeological footprint. The pots alone tell the story. Weller's team found hundreds of broken ceramic fragments at the site, the casualties of a process that involved filling heavy pots with brine and holding them over intense heat for hours at a time. The thermal stress cracked the ceramics constantly. People kept making new ones. The broken pot count suggests Lunca was not used occasionally. It was used continuously, season after season, possibly for generations. And the salt didn't stay there. Chemical analysis of artifacts found at sites up to 100 kilometers from Lunca showed sodium signatures consistent with the mineral profile of the spring at Lunca. The salt was moving, people were carrying it, trading it, distributing it across a landscape too large to suggest anything other than a deliberate distribution network. Salt was already a commodity before bronze was discovered, before writing existed, before any empire rose or fell. Lunca was not alone. Evidence of deliberate salt extraction at China's Yuncheng Salt Lake in the Shaanxi province dates to approximately 6000 BCE, contemporaneous with Lunca. Researchers from the Chinese Academy of Social Sciences found residue patterns and tool assemblages suggesting organized harvesting of surface salt from the lake's evaporated edges. On the other side of the world, along the Peruvian coast, archaeologist David Goldstein documented salt production sites near the Chilca Valley, dating to roughly 5000 BCE, where ancient communities built shallow clay-lined basins to concentrate and evaporate seawater. 3 different continents, 3 different cultures, no contact with each other, all arriving at the same conclusion within roughly the same 1,000-year window. When a behavior appears independently across separate populations at roughly the same time, it usually means something in the environment changed, and something had. Farming had just begun. Grain did it. When humans settled down and began eating primarily wheat, barley, millet, and rice, their sodium intake collapsed. Domesticated grain has almost no sodium. A diet built on cereal crops is a diet that leaves your body chronically undersupplied with the one mineral your nervous system cannot manufacture on its own. The craving that had always been there became unbearable, because now the food wasn't answering it anymore. This is the mechanism anthropologist Mark Nathan Cohen of SUNY Plattsburgh identified in his landmark 1977 work on the health consequences of agriculture. Cohen analyzed skeletal remains from pre-agricultural and post-agricultural populations across multiple regions and found consistent evidence that early farmers were less healthy than the hunter-gatherers who preceded them, shorter in stature, more prone to dental disease, and showing bone markers consistent with nutritional deficiency. Sodium deficiency doesn't leave a clean signature in bone, but the broader pattern was clear. Farming made people worse off nutritionally, at least at first, even as it made them more numerous. Salt didn't become precious because humans suddenly decided they liked the taste. Salt became precious because farming made deficiency the default, and once deficiency was the default, control of salt became control of survival. Picture a morning at Lunca 8,000 years ago. The air is cold. The spring nearby smells slightly mineral, slightly sulfurous. A group of people carry heavy ceramic pots to the water's edge and fill them with brine. They build fires and tend them for hours. The pots crack from the heat. They make new ones. When the water finally evaporates, a crust of white crystals is left behind. They scrape it out carefully. They wrap it in leaves and animal hide. Some of it they use. Some of it they carry elsewhere. That elsewhere is the beginning of every salt trade route in history. We traded the nutrient-dense organs of wild animals for fields of grain. We invented agriculture and accidentally created a sodium crisis. We eliminated the natural sodium sources from the human diet and then spent the next 8,000 years trying to replace them with extracted mineral. Every Roman soldier paid partly in salt, which is where the word salary comes from. Every ancient Egyptian mummy preserved in natron, a sodium compound, because sodium was so fundamental to their understanding of preservation and purity that they used it on the dead. Every salt road that crossed the Sahara, connecting sub-Saharan Africa to the Mediterranean world, was built on the same desperation your Neolithic ancestors felt when the grain they'd planted gave them calories but stripped them of sodium. The Timbuktu salt trade at its peak in the 14th and 15th centuries moved slabs of Saharan rock salt called taglamt, cut from the mines of Taghaza in what is now Mali, across 1,000 kilometers of desert to be exchanged, sometimes weight for gold. Weight for weight, salt and gold equal on the scale. Because in a farming world, far from the sea and far from mineral springs, salt could keep you alive, and gold could not. We invented empires partly to control it. We drew borders around it. We taxed it. In 18th century France, the gabelle, a salt tax, was one of the most reviled instruments of royal power, applied unevenly across regions, brutally enforced, and deeply connected to the popular fury that eventually fed the revolution. Gandhi's 1930 Salt March in India was not a protest about seasoning. It was a protest about survival, About a colonial power taxing a substance that 1 billion people's bodies required to function. That is what salt is, not a condiment, a controlled substance. A mineral that governments understood long before nutritional science existed was so necessary that whoever controlled it controlled everything else. And then something strange happened. Salt got cheap. Industrial evaporation, mechanized mining, global shipping. In the span of roughly 150 years between the mid 1800s and the mid 1900s, salt went from a precious commodity to one of the cheapest substances on the planet. Today, a kilogram of table salt costs less than a cup of coffee. It is in almost every processed food you eat, added invisibly before the package ever reaches you. The scarcity ended. The craving did not. Your nervous system, your gut, your kidneys, your cardiovascular system, they are all still calibrated for a hunter-gatherer's sodium intake. Roughly 700 milligrams per day from natural food sources. The average modern person in the United States consumes about 3,400 milligrams per day, nearly 5 times that amount, almost entirely from food that has been salted before you touch it. And yet the craving doesn't turn off. Your brain doesn't register enough. Because the system that evolved to chase down a rare and vital mineral in a landscape that hid it was never designed for a world where sodium is inside everything. Invisible, pre-added, inescapable. In 2011, neuroscientist Wolfgang Loescher of the University of Veterinary Medicine Hanover published research showing that sodium deficiency activates the same reward pathways in the brain as addictive substances, flooding the nucleus accumbens with dopamine when sodium is finally consumed. The relief of salt is not metaphorical. It is neurochemical. Your brain is rewarding you for finding something it believes is rare. It has not been told that it isn't rare anymore. You are running ancient software in a modern environment. The software is doing exactly what it was always supposed to do: chase sodium, signal relief when you find it. Never fully switch off the alarm because for 300,000 years, switching it off would have killed you. The alarm is still running. It was calibrated for a world that no longer exists. Sit with that for a moment. Somewhere in northeastern Romania, 8,000 years ago, a person crouched over a cracked clay pot and scraped white crystals from the bottom with their fingernails. They were solving the same problem your body is trying to solve every time you reach for the shaker. They just had to work harder for the answer. The salt on your table is the end of a 300,000-year search. Your ancestors tasted it in blood and clay and mineral spring water. They followed elephants to find it. They boiled brine for hours in pots they knew would break. They carried it across deserts and paid for it with gold. They built empires to control it and revolutions to take it back. And now it sits there, 2 feet away, unremarkable. The craving is still there. The search is just over. If you made it this far, you are exactly the kind of person this channel exists for. We make videos like this one every week, about ancient human behavior, about what your body still remembers, about the gap between the world you were built for and the one you actually live in. If that is something you want more of, hit subscribe. It costs you nothing, and it tells the algorithm that this kind of storytelling is worth keeping alive. See you in the next one.